All right, today we're going to talk about some complex numbers. Now, the name is quite deceptive in our complex numbers because honestly, they're not so complex. If we're looking at a complex numbers, let's look at a little background information. If you have the square root of 4, what's that? 2, right? Because 2 times 2 gets you 4. Well, what happens if you want the square root of negative 4? Is there anything that multiplies by itself to give you that? No, because of that, introduce complex numbers. Awesome, so it gives you something that's a negative under a square root, where in intermediate algebra we learned that was just not a real number. Now we're going to get a chance to look at that and say, oh, okay, well, let's go ahead and break that down. So if I have the square root of negative 4, you can start breaking that down with something called a complex number. And here it is. If you have the square root of a negative 1, that is I. And I is an imaginary number. So who says mathematicians aren't creative? We have imaginary numbers. Woohoo! So as soon as you have something like this, now we have an I, you can use the product rule with radicals and break this up to be the square root of negative 1 times the square root of 4. Well, the square root of negative 1 is I, and the square root of 4 is 2. So you get 2I. Da-da-da-da-da-da. See, it's not so bad. What if I have this? Okay, so we now know that the square root of negative 1 is I. So what if we square that? If you square a square root, so that's going to give me an I squared, right? So when you square a square root, those cancel. So that now means if the square and the square root cancel, I'm just left with a negative 1. So I squared actually equals negative 1. So that's awesome. If you have I, so the square root of negative 1 is I squared equals negative 1. Those are the two main concepts you need to know about complex numbers. So whenever you're looking at a complex number, it's really just dealing with radicals. That's what your complex number is. So let's check this out. If I end up with something like example 1a, okay, we have the square root of negative 16. As soon as you see a negative sign under the radical, automatically pull out an I. So we now have the square root of 16, we know is 4, and then that's I. That's it. Not so complex, is it? Look at example 1b. We have the square root of negative 70. So right off the bat, we're going to pull out an I. But if I look at 70, can you break that down anymore? Is there anything you can do to break down square root of 70? If you're struggling with doing your radicals, go back to those review problems I have at the very beginning that are not for a grade. But the square root of 70, we're done. Now notice where that I is. I'm going to write that in front of my radical. And the reason for that is because if I put it behind there, I don't want it to look like the square root of 70 I, and I'm wondering, is that I under the radical? I'm not real sure. So if you don't know, put that in front, and that's the best way to write it. Cool, check this out. So if I have example 1c, where we have the square root of negative 48. Now, as soon as you see that I automatically, or pardon me, that negative under the radical, automatically take out that I. Now look at 48. Can you break that down? Yes, you can. And again, this is breaking down your radicals, so that's up to you. If you look and see the greatest thing you can break down, that's what you want to try to take out. So I now have the square root of 16 times the square root of 3. So the square root of 16 we know is 4. There it is. 4I root 3. See, it's not so bad. This stuff's pretty cool. In the same way you know to break down a radical by splitting it up, guess what? We can put them together the same way. That's awesome. Let's do some right now. So if we have example 2a, and we have the square root of negative 7 times the square root of negative 7. So I'm multiplying those two things together. Now here's the super amazing part. As soon as you see a negative under the radical, what are you going to do? Pull out that I. Good job. So this is really I root 7 times I root 7. Now you can combine those. Don't do it beforehand, because if you do, you're going to miss that I component. Because a negative times a negative would typically be a positive and you lose it. So make sure you're pulling those i's out first. Now, I times I is just an I squared. And the square root of 7 squared, check it. The squares and the square root cancel, rock on. And what did we just learn I squared was? -1. So we actually have a -7 as our answer. So do you see the difference? If you'd gone through here and you had -7 times -7 and you multiplied those together, that would have been a positive 49, giving you just a plain 7. So you would have missed this negative sign that you need to show that you started with that -7. All right, pretty cool, right? Let's do some more. Cool, that last one was kind of obvious because it was the exact same thing, so it was obvious that it canceled out. What if I have something super awesome, like example 2b? The square root of -6 times the square root of -10. That's a times in the middle. Cool, as soon as you see a negative, what up? Pull out that I, right on. Let's do it right now. So if I have I root 6 times I root 10, so I times I is an I squared, and then look at 60. Can you break that down? Is there anything that's a perfect square that goes into 60? Well, I don't know. If you were looking at 60 and you can't make that determination, off to the side, make your list. So you know that 2 squared is 4. Does 4 go into 60? Whammo jabammo. And we know that this I squared is a -1. So we have negative square root of 4 times the square root of 15. Cool. So -2 root 15, and that's our answer. See, these things are called complex numbers, but they're not. This stuff is super easy. You've totally got this. Let's do more. We can multiply, and what else can we do? That's right, do a little division. So if I have example 2c, the square root of -20 over the square root of -2. Same thing applies. As soon as you see that negative, pull out that I. So I have I root 20 over I root 2. Now, this is division, so divide. I divided by I cancels out. And if you have the exact same radical, then you can combine that. So this is really 20 divided by 2, which just gives me the square root of 10. And there's nothing else I can do to break that down. So done. What if, and I know how much you love it when I say that, what if we have something super awesome like the square root of -48 over the square root of 24? There's only one negative under a radical. That's no big deal. That's the only one you take the I out of. So I now have I square roots of 48 over the square root of 24. It's okay that 24 doesn't have a radical. That's no big deal. Now, some of you may be at this point thinking, ooh, I need to rationalize that denominator and break that down. Too much work. Don't put yourself through all that agony. If you have the exact same radical, and in this instance, mean by the index, and that's both a square root, so I now have I, big fat square roots, of 48 divided by 24. Well, what's 48 divided by 24? 2. Done. So you don't have to worry about rationalizing the denominator. If there's a radical on top and a radical on bottom, take care of that business first. Make your life easy. That's the ultimate goal with all of this. Cool, you guys are owning this stuff. Guess what? Let's do more. Okay, something we haven't talked about is how to write your answer if it has an I. We haven't really had a whole lot to deal with, but standard form for complex numbers is A plus BI. Now the A in this instance is a number, and so is the B. And I, of course, is our imaginary. But look where that I is. It's in the back, right? And there's a reason for that. You will only have 2 terms in standard form. That's it. You'll have a number plus or minus, depending on what you have, that BI. So your I is in the back because if you think about this, how do you typically write something in descending order? So if I have like 2 plus 3x, you wouldn't write it like that, right? You would write it as 3x plus 2. The whole reason why the I is in the back is, let's say I'm talking about igloos or some crap, I don't know. If I'm looking at this, you want to say 3I plus 2 in reference if I is igloos. But if it's in standard form, you have your 2 plus 3I. There's no question, I'm not talking about igloos here. I'm talking about imaginary numbers. So standard form always has to have that I in the back, and that's how you know it's standard form. Okay, cool, let's do more. Okay, check this out. We have example 3, negative 8 plus the square root of negative 128 all over 4. And we want to write our final answer in standard form. Okay, we got this thing. As soon as you see a negative under the radical, what are you thinking? Pull out an I. Let's do it right now. So I have negative 8 plus I square roots of 128 all over 4. Now you can take 128 and break it down, break it down, break it down. If you look at it, you can say that the square root of 64 times 2 gives you 128. So the square root of 64 we know is 8, so that is what comes out in front. So I now have negative 8 plus 8I square roots of 2 all over 4. Anytime you divide by that monomial, which is just means single term, so anytime you're dividing by a monomial, you can split it up. And that's going to put us in the form of A plus BI. So I want 2 terms here, and that's why we're going to take the 4 and divide it into each one. So this is really negative 8 divided by 4 plus 8I root 2 divided by 4. Then reduce. We got this thing. Negative 8 divided by 4, negative 2. 4 goes into 8 2 times, and so I'm ending up with 2I root 2. Now here's my question for you. Can you divide 4 into this square root of 2 in the denominator? No siree, that's right. The 2 is underneath the radical. You cannot touch it. The only thing that's up for simplifying are things that are multiplied. Anything that's under the radical, you can't multiply. Like over here, I cannot, not, take out this 4 and this 8 only. Those of you that were in intermediate algebra know that I will chop off your hand. You cannot cancel anything touching a plus or minus. Only when it's multiplied. Cool. We got this. Nice job.